Imagine you're just sitting on your couch, right? You're streaming a movie in pristine 4K resolution. You press play, and instantly the video begins.
Just like magic.
Exactly like magic. But to actually get to your screen, that video data just traveled as literal pulses of light across the bottom of the Atlantic Ocean, bounced through a, repurposed television cable from the 1980s, and then flew invisibly through the air in your living room.
And all of that happens in a matter of milliseconds.
Right. It's wild. So welcome to the deep dive.
Glad to be here.
Um,
Because, it's entirely invisible to us, yet it's probably the most complex machine human beings have ever built.
It really is. It's a lot like looking at the architectural blueprints of a house you already live in.
Oh, I like that.
Think about it. You wake up, you turn on the tap, water comes out, you flip a switch, the lights come on. You and I and everyone listening right now, we use the plumbing and the electricity of our digital world every single day.
We absolutely do.
We live in this house, but we rarely pause to actually look at the schematic, to understand how the pipes and wires actually connect us behind the drywall.
And, that infrastructure is shifting so rapidly. The tools we rely on today, they operate on principles that would have seemed like outright magic just a few decades ago.
Which perfectly sets up our mission for today. We are unpacking a foundational post from November 2023. It was published by Support Tips, and it's simply titled Communication Technology.
It's a really great overview.
It really is. It lays out these concepts so systematically, revealing the invisible nervous system of our modern world.
Yeah, and to start us off, they define communication technology basically as the tools, systems, and processes used to transmit, receive, and exchange information between individuals or entities.
So it's the entire ecosystem connecting people, organizations, and devices.
Exactly.
Yeah.
And that definition is crucial because it forces us to look past the smartphone in your hand. The phone is just the terminal. To really understand how we exchange ideas, we have to look at the physical methods of moving data, the actual tangible infrastructure that allows that data to travel from point A to point B.
Right, because before we get to the, slick digital apps on our screens, we have to literally move the zeros and ones across the planet.
We do.
And the foundational piece of this physical web is fiber optics. We always think of the cloud as being up in the sky, right?
Yeah, naturally.
But something like 99% of international data is actually at the bottom of the ocean running through glass tubes.
It is a remarkable feat of engineering. Instead of sending electrical currents over heavy copper wires, which is what we did for over a century with telecom, fiber optics rely on thin strands of glass or plastic.
Like, how thin are we talking?
We're talking about fibers roughly the diameter of a human hair.
Wow.
Yeah. And data is transmitted through these strands as rapid pulses of light.
So if I'm visualizing this correctly, is it basically like an underground or, I guess, underwater superhighway for data? You just shoot a laser beam down a glass pipe.
Well, it is a superhighway, yes. But the real genius is in the physics of the glass itself. It relies on a principle called total internal reflection.
Total internal reflection.
Right. So when that pulse of light travels down the fiber, it doesn't leak out the sides. It bounces off the internal walls of the glass perfectly.
Oh, I see.
Meaning it can travel thousands of miles across entire oceans with practically zero loss of signal strength.
That's incredible.
And obviously light moves incredibly fast, which is why we get the massive bandwidth required for today's high-speed internet.
So it's a literal speed of light superhighway.
Exactly.
But, fiber optics have a physical limitation, right? You can't run a delicate glass thread to every single pair of wireless headphones or every laptop moving around a coffee shop.
No, you definitely can't. That physical limitation forces us to look for localized solutions.
Which brings us to wireless technology,
Okay.
Wi-Fi and Bluetooth. So if fiber is the superhighway, Bluetooth has to be like a short, temporary footbridge built directly between two nearby devices, right?
A footbridge is a pretty good way to picture it, but it's a highly chaotic, rapidly shifting one.
Chaotic how?
Well, unlike a static bridge, a Bluetooth connection doesn't just sit on one frequency. To make sure your wireless headphones don't pick up interference from your neighbor's Wi-Fi router or, a microwave oven, Bluetooth actually hops between different radio frequencies thousands of times a second.
Wait, really? It's constantly changing lanes.
Constantly, it takes the data, chops it up, and transmits it across a rapidly changing spectrum of frequencies. And only your two sync devices actually know the pattern.
That is wild. I had no idea it was jumping around like that.
Yeah, it's a very active process.
Yeah.
And Wi-Fi operates on a somewhat similar concept, but with vastly more power.
Because it has to cover the whole house?
Exactly. It translates standard electrical data from your router into radio waves that are actually strong enough to bounce through the drywall of your house without losing the integrity of the message.
Well, that explains why the connection can sometimes be finicky if there are too many walls in the way.
Definitely.
Now, here is a piece of infrastructure from the source that genuinely surprised me. Cable television.
Oh, yes, the coaxial cables.
Right, we are talking about cutting-edge internet and data, but coaxial cables, the thick, round wires we used to screw into the back of heavy tube TVs, they are highlighted as a major pillar of communication tech.
They really are.
But these cables were put in the ground just to send us channels of television, right? How did they become a vehicle for internet and phone services?
It basically comes down to a brilliant engineering adaptation, mostly driven by sheer necessity.
Okay, lay it on me.
Well, coaxial cables are structurally completely different from the old copper wires used for traditional landline telephones.
Mm-hmm.
A coaxial cable has a copper core, sure, but it's surrounded by a thick layer of insulation and then wrapped in a woven metal shield.
So it's heavily armored.
Exactly. It's built like a tank.
Right.
That shielding keeps outside electromagnetic interference out, and it keeps a massive amount of data required for rich video signals in.
Makes sense for TV.
Right. And because it was designed to carry dozens of heavy video channels simultaneously, it naturally had massive bandwidth.
Oh, I see where this is going.
Yeah. When the internet revolution took off, engineers realized they didn't need to immediately dig up every single street in the world to lay new wire.
Because the wire was already there.
Exactly. They could just use the excess unused frequencies within those existing TV coaxial cables to transmit internet and voice data right alongside your television programming.
That is incredibly clever. It's like finding out the heating ducts in your home can somehow be magically repurposed to also deliver your mail without doing any extra construction.
That's a great analogy. We have a massive shortcut to getting broadband into homes.
But even with coaxial cables and glass fibers, you still have to physically reach the location.
True.
What happens when you need to connect a cargo ship in the middle of the Pacific or, a remote research station in Antarctica? You obviously can't lay a cable for that.
Right, which forces us to look up. Satellite communication is the mandatory next piece of the puzzle here.
Right.
When you cannot run a physical line, you basically just bounce the signal off a device orbiting the Earth.
So satellites are essentially giant mirrors in the sky.
Right. In a functional sense, yeah, pretty much.
Yeah.
A ground station beams a high-frequency radio signal up into space. The satellite catches it, amplifies it, and then blasts it back down over a massive footprint on Earth.
Okay.
This is how we get television broadcasting, GPS navigation, and satellite internet in incredibly remote areas. But there's a massive physical trade-off here, latency.
Because of the distance it has to travel.
Right. I mean, many traditional communication satellites sit in geostationary orbit. That's about 22,000 miles above the Earth.
Wow, 22,000.
Yeah. So even at the speed of light, it takes a fraction of a second for a signal to go up 22,000 miles and then come all the way back down.
So when you are on a satellite internet connection, you will often notice a slight delay.
Exactly. It's just the inescapable physics of the commute.
Right. So to recap this physical web, we've got pulses of light shooting through glass fibers, data squeezing through armored coaxial cables, radio waves hopping frequencies in our living rooms, and giant mirrors catching signals 22,000 miles in space.
It's quite the list.
And we still have traditional telecommunications too, right? The vast network of copper wire supporting standard landline phones alongside our mobile networks.
Yeah, that is the foundation. Every single piece of digital magic we experience relies entirely on that physical layer functioning perfectly.
Right. And building off that physical layer, we shift from the infrastructure to the methods of broadcasting and messaging that actually ride on those pipes and airwaves.
Which naturally brings us to radio and television broadcasting.
Right. Transmitting audio and video signals over the airwaves to be received by the masses. But right next to those traditional mass media tools in the source material, we hit a categorization I kind of want to push back on.
Oh, what is that?
The categorization of internet technologies. The source lists the internet itself.
Okay.
Is it actually accurate to call the internet a single communication technology? Or is it more of a massive environment where all these other technologies live?
That's a fair question.
Because when I think of the internet, I think of a place. like an umbrella under which email, video calls, and social media exist.
It's a very common debate, actually, and I see why you'd think of it as a location or a medium.
Hmm.
But from a strict infrastructural and computer science standpoint, the internet absolutely is a technology.
Really?
Yeah, it's not just a vague cloud, it's a rigid set of protocols.
Protocols meaning like the rules of the road.
Precisely. The internet is fundamentally built on something called packet switching.
Okay, packet switching. Walk me through that.
Sure. Let's say you want to send a high-resolution photograph to a friend across the country. In the past, to send information, a continuous, dedicated physical circuit had to be held open between you and your friend.
Like the old telephone operators physically plugging a wire into a switchboard to connect two houses.
Exactly. You needed a dedicated line.
Yeah.
But packet switching completely revolutionized that. The Internet Protocol takes your photograph and chops it up into thousands of tiny digital envelopes, or packets.
Oh, I see.
Each packet has a destination address on it. Those packets are shoved into the physical web. Some might travel through a fiber optic cable in Chicago. Others might bounce through a coaxial cable in Denver.
So they all take different routes.
Yes, highly efficient, independent routes. And then once they arrive at your friend's device, the protocol reassembles those thousands of packets back into a single photograph instantly.
Oh, wow. Okay, I get it now. So the internet is the underlying mechanism, the sorting and routing intelligence that makes the whole environment possible.
Yes, exactly. It is a system used to transmit, receive, and exchange information, which fits the definition of communication technology perfectly.
It just happens to be a foundational technology that hosts other applications on top of it.
Correct.
And living on top of that packet switching protocol is perhaps the most fundamental digital tool of them all. Email.
Ah, yes. Good old email.
We all use it, we all complain about it, but when you look at its mechanical function, it is the undisputed workhorse of the modern world.
It genuinely is the grandparent of the modern web.
Because it isn't just messaging,
Yeah.
right? Think about the last time you sent a massive PDF or a spreadsheet over email.
Right.
You didn't have to coordinate a specific time with your coworker to receive it. You just attached the document, hit send, and walked away.
Exactly.
That ability to collaborate asynchronously fundamentally decoupled communication from time.
And that was the revolutionary leap. I mean, before email, business communication was almost entirely synchronous.
You had to be on the landline at the exact same moment.
Right. Or you had to wait days for physical mail. Email allowed you to send a complex idea with attached data, and the recipient could process it and respond precisely when they were ready.
Which really laid the groundwork for the entire concept of remote work.
It absolutely did.
But, as human beings, we eventually get impatient.
We always do.
Asynchronous collaboration is great for deep work, but there is always a demand to get back to real-time, face-to-face connection, which drives the next massive leap the source talks about, video conferencing and voice-over internet protocol, or VoIP.
Right. The demand for immediacy is always the driver of the next wave of innovation. We wanted the instant connection of a phone call, but we wanted to bypass the limitations and the huge costs of the old telecommunications networks.
Now, I obviously know what video conferencing is, but VoIP is fascinating to me because it seems to be the quiet engine behind almost everything we do now.
It really is.
Services like Skype and Zoom run on VoIP, but what exactly makes it so special compared to just, picking up a regular phone?
It goes right back to that concept of packet switching we just discussed.
Oh, really?
Yeah. Traditionally, a phone call required that dedicated continuous circuit over copper wires. You're renting a physical line from your house to someone else's house.
Which is why long-distance calls used to cost an absolute fortune.
Exactly. You were paying for the exclusive use of that wire for the duration of the call.
Right.
VoIP completely destroyed that business model. Voice over Internet Protocol takes your physical voice, digitizes it, breaks it down into those tiny data packets, and sends them over the internet right alongside emails, Netflix streams, and regular web traffic.
Oh.
And then it reassembles your voice instantly at the other end.
So instead of a dedicated physical pipe just for my voice, my audio is chopped up, shoved into the digital superhighway basically for free, and then reassembled in milliseconds.
Yes. It is wildly more efficient, which is why you can have a 3-hour voice and video call with someone in Tokyo over the internet without paying a single cent in long-distance telecommunication charges.
That is amazing when you frame it like that. And we see that same evolution happening on our mobile phones with messaging apps, right?
Oh, for sure.
We went from basic SMS text messaging, which relied on the cellular network's old restricted protocols, to apps like WhatsApp, Telegram, and Signal.
Which, crucially, also ride entirely on the Internet Protocol.
Right.
That is why they aren't limited to plain text. They effortlessly handle voice notes, high-resolution photos, and massive group chats, all completely bypassing the traditional cellular text messaging infrastructure.
But here's the problem that arose from all this rapid innovation.
The clutter.
Exactly, the clutter. Because we suddenly had all these amazing individual tools. We had standalone email clients, standalone VoIP software for video calls, desktop phones, mobile messaging apps.
It was a lot to manage.
The daily workflow got incredibly chaotic. You were constantly jumping between different windows and devices just to talk to your team.
And that friction leads us directly to the concept of unified communications.
Right.
It's the natural reaction to application overload.
Yeah.
Unified communication systems basically integrate voice, video, email, and instant messaging into a single cohesive platform.
So it is basically a digital Swiss Army knife.
I like that.
Think about the friction of the past. You had a standalone phone on your desk. You had a separate mail application on your computer screen. You had an entirely different piece of software you had to launch for video calls.
It was exhausting.
Right. Unified communications is like taking all those distinct separate tools and folding them into one single handle. You open one platform, and every conceivable way you might need to communicate is right there in the same window.
The Swiss Army knife is a great analogy because the primary benefit is the elimination of context switching.
Context switching.
Yeah, you don't have to hang up the phone to look at an email or close your chat to start a video call. The cognitive friction of moving between modes of communication is completely erased.
And speaking of erasing friction, there is a specific technology under the real-time umbrella that operates almost entirely behind the scenes, but its implications are massive. WebRTC.
Web real-time communication.
Yeah, right.
This is a monumental leap forward, even though most people have probably never heard the acronym.
So as I understand it, WebRTC allows web browsers to facilitate real-time communication directly through APIs.
Correct.
This enables features like video chatting right within a standard web browser without needing to download a separate program.
Exactly.
Now, wait. If an ATI is essentially a digital bridge that lets different software talk to each other, and WebRTC builds the video and audio capability directly into our web browsers, doesn't that make standalone VoIP apps eventually obsolete?
That is exactly the tension this technology introduces to the market. I mean, think about what it was like to make a video call before WebRTC.
Oh, it was a whole process.
It was. If you wanted to chat with someone, you had to find out what software they used. You'd say, do you have Skype? No, you have this other program.
Right.
Then you had to go to a website, download a heavy application, install it, create an account, add them as a contact, and then finally ensure you both have the software open at the same time.
It was a total nightmare. The friction to just say hello on video was huge.
But WebRTC bypassed all of that. It standardized the protocols for accessing your computer's camera and microphone and just built them directly into browsers like Chrome, Safari, and Firefox.
That's so smart.
Suddenly, a developer could just generate a web link. You click the link, your browser asks for permission to use your camera, and boom, you are instantly in a video call. No downloads, no installations, no accounts required.
It literally turns the browser itself into a universal communication terminal. It completely democratizes video chatting.
It really does. Now, to your point about obsolescence, the standalone apps haven't entirely died out because they adapted.
How so?
They started offering robust enterprise features, advanced screen sharing, massive webinar hosting, and end-to-end encryption, stuff browsers struggle with natively.
Yeah, that makes sense.
But for pure, frictionless, instant connection, WebRTC changed the fundamental architecture of how we meet online.
So let's zoom out and look at the macro impact of all this. All of these integrated real-time tools, the transoceanic fiber optics, the packet switching VoIP, the frictionless WebRTC, they all culminate in platforms that completely reshape human behavior. And the ultimate expression of this is social media. Platforms like Facebook, Twitter, Instagram.
They really represent the synthesis of everything we've discussed today.
They do.
They facilitate mass online social interactions, instant information sharing, and global content dissemination, all riding on top of that underlying infrastructure.
And here is an observation from the source that really struck me. Earlier, we talked about traditional radio and television broadcasting. The mechanism there is a one-way street. A few massive corporate broadcasters transmit signals out over the airwaves to millions of passive receivers. You just sit on your couch and watch.
A heavily centralized model of communication.
Exactly. But social media combines social interactions with content dissemination.
Yes.
And by merging those two concepts, it effectively turns every single user into their own broadcasting station. You aren't just the passive receiver anymore, you are the radio tower.
And that is the pivotal transformation of the 21st century.
It really is.
The barrier to entry for global content dissemination dropped to absolute zero. You no longer need a $1 million television studio, an FCC license, and a giant broadcasting tower.
Nope.
You literally just need a piece of glass in your pocket and a Wi-Fi connection. And you can instantly transmit a high-definition video message to millions of people.
It is staggering when you actually stop to think about the scale. It transforms the way people connect on a personal level, but it also fundamentally alters massive global industries.
You really cannot separate modern industry from this technology. Think about healthcare.
Okay.
Telemedicine is entirely dependent on this stack working perfectly. A doctor can examine a patient remotely because fiber optics carry the heavy data, the internet protocols route the packets flawlessly, and WebRTC allows the browser to display real-time, high-resolution video without dropping a frame.
The same goes for global business logistics or, remote education. We have essentially taken the friction out of distance.
We have. And the innovation isn't slowing down. The ongoing evolution is entirely focused on enhancing speed, boosting reliability, and increasing the sheer volume of data we can push across the globe in real time.
The pursuit of zero latency is never ending.
Never ending.
So let's take a breath and recap this incredible journey we've just been on. We started beneath the ground and up in the sky.
We did.
We looked at the physical strands of glass and fiber optics using light to carry our data. We saw how armored coaxial cables from the TV era were brilliantly repurposed to deliver the internet.
We explored the inevitable chaos of Bluetooth frequency hopping and the necessary latency of bouncing signals off satellite mirrors 22,000 miles in space.
Right. And from there, we moved up to the digital layer, exploring how the internet isn't just a place, but a strict protocol of packet switching that chops up our data and routes it globally.
And we saw how email decoupled our communication from time, acting as the grandparent of remote work.
Then we traced the demand for immediate connection. We saw how VoIP digitized our voices to bypass expensive phone circuits, how unified communications eliminated the friction of context switching, and how WebRTC turned our standard web browsers into frictionless video terminals.
It's quite the technological stack.
It is. And finally, we looked at the macro impact, how social media platforms utilize all of this incredibly complex infrastructure to turn every single one of us into a global broadcaster, altering everything from daily friendships to international healthcare.
It truly is like looking at the blueprints of our daily lives. Once you see how the pipes connect, you never really look at a simple video call the same way again.
You really don't. But, seeing those blueprints leaves me with